Good morning, nerds. Today's tutorial is on making things bouncy. So thank you for joining us. This is another round of Unity Gameplay Basics. And today what we're going to look at is making bouncy balls. And for this one, because it's fairly quick and pretty straightforward, I'm combining the tutorial for 2D and 3D into the same tutorial. So about the halfway mark, give or take, we're going to switch over to the 3D project that we started earlier. I think in tutorial 3, maybe? Anyways, we'll pick up that project and we'll look at making bouncy objects there as well. So we're going to start in 2D, we'll move into 3D in a moment. So adding in bounce factor is really pretty easy. What I've done here since the last time we've looked is I did add this ball sprite, which again I made at piskelart.com. And basically, it's just a 16 by 16, actually, no, it's 32 by 32 ball. I could scale it, but I kind of liked how it looked in proportion to my paddle. So we're just going to go ahead and work with that. First thing I'm going to do is go ahead and add this into, actually, whoops, this is still my prep one, so I'm just going to delete this. Bye, ball. Okay, we're going to go ahead and start over here. I wanted to make sure I didn't add anything else here. So we're going to go ahead and add in a ball. And again, we just drag and drop that in there, and that is going to put it kind of behind this camera icon there. So I'm just going to kind of slide it over this way. Let's go ahead and kind of put it a little left to center. But it doesn't really matter where it's positioned for this. So we're going to look at how to go ahead and add bounciness. There's a lot of really cool code ways to do this. For this one, though, we're just going to use the Unity built-in system. We're going to write a little teeny tiny bit of code to get a velocity going when we take away gravity. But it's going to be literally one line of code, so nothing too painful here. So if we look at our objects, as usual, we've got our components here. All I've got on here is a sprite render and a transform right now because we just use the default sprite. What I'm going to need to do is I want to be able to bounce off the walls. That's going to require two components. The first one is, of course, collider 2D, and for this one I'm going to use a circle collider because I've got a circular object and it just makes sense. So I'm going to go circle collider 2D. And you know, when you're working with colliders, we haven't really talked about this a whole lot, but you want to use the one that has the least amount of sides as often as possible. A circle collider is really handy because literally it only has one side, and the calculation for collision is much cheaper than using a cube or a square or a box or some of those other colliders, and especially when we get into 3D, like using mesh colliders is super expensive. So a circle collider is really cheap. So we're going to go ahead and use the circle collider. And if we zoom in on this, you don't have to do this part, but if we zoom in on this and look at the collider, what we see is that collider has really just matched itself to the circle, and that looks really nice. So I'm pretty happy with this collider. We'll go ahead and turn that off, and that's pretty good for the collider part of this. And then the next thing we're going to do, because we're going to be using physics, is just like last time, we're going to add a rigid body 2D to this. And that's going to allow us to handle all of our physics stuff. In fact, you can see material, it has a physics material 2D built into it. You can also add those to the box colliders and stuff. That helps with things like friction and things like that. So for example, like my walls, I could add friction to my walls, even though I might not want to make them full physics objects. And that's why there is a material there as well. I haven't really played with the interplay between the two, so I would just recommend you use one or the other. Don't use both. But I've tested everything with rigid body 2D, so that's what we're going to work with here, is using the rigid body 2D. I'm going to go into my assets folder, and I'm going to right click. We do need to create a new physics material, and one of the mistakes I made during my prep was I came down here and I was just like, oh, create physics material. But this is not actually going to work. We need the 2D version of this. And the 2D version is if we go all the way up to the top, there is a folder for 2D stuff. And you can see physics material 2D. That's the one we're going to want to use. So if we click on that, you'll see a new physics material. And we should name these just to be on the safe side. So I'm just going to call this ball physics. And we're going to go ahead and click again on the ball. And we're just going to drag this into the physics material 2D box on the ball. And what we've really done is we've basically said, hey, we're going to create some properties here about the ball's friction and bounciness and things like that. So if we click on this ball physics once, that's going to show up in the inspector. There is not a whole lot to edit here. There is literally two options. And so what we're going to do is we're just going to set the bounciness. We're going to change that from a 0 to a 1. And since the ball is currently affected by gravity, we're just going to hit play and see what happens. And this is probably going to give us a pretty okay result, actually. So we hit play, and the ball bounces, and it's basically going to keep on bouncing. It bounces kind of a little higher, it seems like, each time. It's about the same spot. It is bouncing a little higher each time. So every time the ball bounces, it is getting just a little higher. I don't know if I like that or not, but there we go. We could adjust that if I wanted to reduce that number or even increase that number, because it is really bouncy. We could, again, go to the ball physics, and I'm going to do this while the project is running. But you can start to see it's even bouncing off the other one now, so that's going to make it even more because of gravity. But I'm going to reduce that bounce. So I'm going to go to 0.5, and we're immediately going to see, although now that it's bouncing off the other wall, I don't know if this is going to be pronounced enough. Let's go 0.2 and just really lower it. I think because we're already hitting gravity, let's go ahead and just stop this. We're going to come back in. Let's see what happens here. I think we already got it bouncing too hard, and it's just not going to want to change much. Okay, at 0.2, it basically just hits the ground and stops. Let's play around with this number a little bit more. Let's go 0.6 maybe. And that's really not bouncing very far, and gravity finally kind of grabs that. So we can adjust that gravity to be whatever we want it to be, and that's going to, or not gravity, I'm sorry, excuse me. We can adjust that bounciness to do whatever we want, and it's going to just kind of maintain that bounce. And gravity's kind of working with it, and all the other physics kinds of things are working with it. The other thing that we could do is we can mess around with the mass of the ball. So if I change that to like a 5, that should affect the bounciness a little bit, but I don't know if it's going to do a whole lot. I didn't actually test this during prep, so let's see what happens here. It's not doing too much, so we can just leave that alone. I'm going to just leave my mass at 1, but definitely messing with that bounciness factor did do something here. And if we take this same bounce and actually apply it, I'm going to apply it to the bottom wall. I'm just going to use the same ball physics, which now it's kind of badly named, but that's okay. We're going to make them both bouncy, and what I'm hoping to see is that it bounces a little higher than it was before, because the ball's getting some bounce off of the. It's getting a little bit more bouncy. We're getting a little bit of bounce off of the ball, and then we're also getting a little bit of bounce off the wall. So, but it didn't change a whole lot. Okay, so what we want to do now, though, is if we're trying to do Pong, we don't really have gravity in Pong. The ball, it's more of looking at it from a top-down perspective rather than a side view. So gravity is kind of silly. And so what we're going to do is I'm going to just make sure I'm not in play mode anymore, and we're going to go ahead and turn off that gravity. So I'm going to change my gravity scale to 0. Now, here's the thing is the bounce still works, but we can't really tell. And the reason we can't really tell is the ball isn't dropping anymore. So the ball is still pretty bouncy, but we just don't know. And this is where the code comes in. What I'm going to do is just write a quick little burst of code to target that rigid body, just give it a little push, and then we'll be able to mess with it from there. So what I'm going to do here is, we've done this before. I'm going to go down to my add component. I'm just going to create a new script called ball move. Capital B, capital M, and as a reminder, you can't have any spaces in these things, so it's all one word. And I've Pascal cased that there, so capital B, capital M. I'm just going to go ahead and hit enter, create an add, and it has added that script. I'm going to drag it into my scripts folder just because I like to keep my house clean. And then I'm going to go over here and double click on the name of the script. Maybe? Is it going to let me? I'm going to double click on the name of the script here, and we're going to go ahead and edit some code. Now, there's a couple different ways we could do this. I don't want to get too complicated here, but I do want the user to be able to type in a vector. And so what we're going to do is I'm just going to go up here. We're going to create a new public vector2 called direction, and we're going to create a public vector, or no, float for initial force. And down here under void start, we're actually going to do all of this in one line of code. We're going to go, and this is a slightly different trick than we've done before, but we're going to do, we're going to try to access that rigid body using a get component, which we have done before. And I'm going to do get component rigid body 2D. Don't forget the 2D on there. And we do need the parentheses to make that work. But then, now that I've got that, and you're going to notice I didn't do RB equals, and you're going to notice I don't have a rigid body 2D in my variables area. And that's because if I'm only going to do one move with it, I can just use the dot method to pull the property of that rigid body. And what I'm going to do is I'm just going to do an add force function. And we are going to move it in the direction that I specified times the initial force. And we are going to do this, I'm going to drag this so it's a little bit easier to read, as a force mode 2D dot impulse. So we're just going to give it one little push at the very beginning, and that is all. And that is our single line of code. If you wanted to, you could even delete the update function, because we don't even need that anymore. So I'm going to just go ahead and clear that out there just to clean things up a little bit. And I'm going to go ahead and save this, Control S. We're going to go back over here, and we're going to see, if we run it right now, we're going to have some problems. Actually, we won't have any problems, because Unity is going to set some of those values for us. But what I want to do is look at my directions here and my initial force. For my initial force, for now, let's just give it a force of 1. I don't want to mess with this too much. But my initial direction is going to be, I want to move it a little bit in the X direction. But you're going to notice since I'm moving it left, I want to move it towards the paddle. I'm going to move it in a negative direction. So I'm going to say, like, let's say -3. And then I'm going to give it some Y. I could move it up or down, depending. If I use a positive number, it'll move up. If I use a negative number, it'll move down, but it'll still go 0.3. And I want it to go more vertical than horizontal. So I'm going to go Y6. That's going to move it basically kind of this direction. It'll be a little more up than it is to the left. About a 60-degree angle. Not quite, but pretty close. Actually, that might be exactly a 60-degree. I think that is a 60-degree angle. Anyways, so we're going to go ahead and run that. And what we should get is that ball is actually traveling. And I can hit it, and everything is bouncing. Now, what we did notice is I've got a couple problems here. The first one is the ball did manage to kind of get stuck. And that does happen with this method, and that's why there are some better coding methods to do this. But one of the other problems that I had during the demo was, let me see if I can replicate it here, is if the ball hits the paddle too hard, it's also going to, it can potentially bump the paddle. Actually, you know what? I think I may have, yeah, I've already prevented that. Okay, that's why nothing happened. Let's try this again. I already fixed it and forgot to turn that back off. So, I'm going to come down here a little bit. And when the ball hits the paddle, you're going to notice it did some weird things, and that's not what we want to have happen. And the way we fix that is if we look at our constraints, which we've used these before in one of our other projects, what I'm going to do is pop down here on my paddle. I'm going to make sure my paddle is selected in my rigid body settings. I'm going to go down to constraints, and I'm going to do two things. I'm going to freeze the rotation so that way he can't rotate anymore, and that'll prevent that spin that we were seeing. And then also, since the paddles are only supposed to move up and down anyways, I'm just going to freeze my X position. I'm going to leave my Y unfrozen because otherwise I won't be able to move. And when I run this again, now we're going to see the reaction, or the what we saw in the beginning, which was if the ball hits me, it's not going to go anywhere. Now I do have a little bit of friction coming off the paddle, and the ball is definitely slowing down as it goes. I think that's because we're using a 0.6, and what we really want to do is bump that back up to 1, and that's going to allow it to kind of maintain its velocity there. Whoops, not 0.1, we want a whole 1 there. So we're going to run that again. And we should start getting a better bounce, although I'm still getting, I think that's because the wall has got bounce to it as well. So we're going to take that bottom wall, we're going to get rid of the physics material on there. And to get rid of that, you just click in there and you hit the delete key, and that's going to get rid of it. Shouldn't have done so much experimenting. And that's going to allow the ball to move over to the right and hit, and now we're able to kind of serve it back there. We are getting a little bit of weird on the direction of the ball, which wasn't happening before, so now I'm kind of curious as to why that's happening. Let's see. The ball does have ball physics. It's not using gravity. Let's see if the paddle, I think the paddle may have absorbed some of that hit. So what the other thing we can do here is if we turn the mass up to 10, that should make the paddle a little bit more, I don't know, burly, a little beefier. And that's going to make that paddle take a little bit more of a hit, and it should make the ball not bounce as much, but or bounce more directionally. I'm really not sure why we're getting that up and down, because that wasn't happening to me before. Let's change the friction to 0. Whoops, yeah. It might be a friction-related problem. I think the ball might be catching some friction from the walls. Oh, that's looking a lot better. Okay, so it was basically just a friction problem. And again, these rigid body settings, or these physics settings, can be a little touchy. So this isn't necessarily, especially for a game like Pong, where you want it to be pretty predictable on its path. This isn't normally how I would do it. I would probably code a bounce myself. But that isn't bad for a basic system. So I just lowered my friction to 0, my bounciness to 1. That seems to be doing the trick. So I think we're in a pretty good shape. And that's really about it for the 2D part of this. There's not a whole lot more with this. You can also change the friction, as we saw, changing the frictional effect, basically how much stickiness it has. But this is pretty good for what we're trying to do here. And you could use the exact same thing coupled with a gravity scale. For example, if I wanted to do like Super Mario Brothers, like the fireballs, I could have those be launching out, add a little bit of a gravity scale to them, and then some bounciness, and that would allow them to like bounce across the right of the screen. Especially if I turned off that friction, they'd kind of progress off screen, and that would give me a nice little fireball effect. Okay, so that's it for the 2D section. What I'm going to do now is open up my other 3D project, and let's kind of apply the same things that we just learned on the 3D project instead. So I still have my cube in my wall. We made this earlier. What I'm going to do now is I'm going to add to this. I'm going to add a cube, or not, excuse me, not a cube. I'm going to add a sphere. And just like the cubes and the planes and stuff like that, it comes built in with a sphere collider. And again, just like the conversation we had about the circle collider, surprisingly, and this is kind of a shocker to a lot of people, the sphere collider is the cheapest 3D collider there is. So I like to use spheres as often as I possibly can get away with it, just because they are very, very inexpensive colliders. And what I'm going to do here is we're just going to kind of look. That sphere is kind of partway in my cube here. And I'm just going to lift that sphere up off the ground a little bit. I definitely want it to be over top my ground though, so don't move it too far backwards. But I basically moved it negative z axis. So I just took the z axis and moved it backwards. Obviously this is a little too far, but maybe about here. So it's still above the grass, but it's not near the cube anymore. And basically, the setup for this is almost the same as what we just did. So I'm going to come back here down in my materials. I'm going to right click and I'm going to go create a physics material. And the settings are very, very similar. We have some dynamic friction, we have some static friction, so we've got a couple different kinds here. We have our bounciness variable. Now, the interesting thing about this is while we can change the bounciness to be like 6 or 7 if we wanted to on a 2D object, if I type in something like a 5 here, it's only going to be a 1. And that's because basically this treats it as a percentage. So it's really treating it from 0 to 1. So 1 is like 100% and 0 is like 0%. Actually, now I want to test. Can I do negatives? Nope. Okay, so it really is truly just a 0 to 1 scale. So I'm going to give it bounciness 1, and we're going to go ahead and just run that and see what happens. Oh, first off, before we do that, I'm going to go ahead and put that on my physics collider, or on my collider, and I'm going to add a rigid body object. Now you're going to notice in 3D, and this is why I put it on the collider instead. We did it on the rigid body on the other tutorial, or on the other part of this tutorial, but there is no physics material on the rigid body in a 3D object. So that isn't going to work. What we can do here, though, is we can also kind of look at, okay, do we still want to be using gravity? And for this, if I want to make a bouncing ball, I'm going to have to. And we're going to go ahead and hit play. Whoops, that is the wrong Unity window. Let's try that again. I'm going to minimize this. This is not the fastest Mac in the world, obviously. Okay, here we go. And we are going to go ahead and hit play here. And what we should see is, yeah, it bounced, but it didn't bounce kind of the way I'd want it to. There was definitely it just kind of landed, right? So what we can do is we can look at that physics material here. And actually, I should rename that. So this is going to be ball physics again. And we can take a look at this here. Now, what we're looking at is you've got friction combine and bounce combine, and these are two settings that don't exist in the 2D. But basically, they talk about how do these two objects, because both of them do have material properties, how do they interact with each other? And so what we're doing is we're averaging, and so we're saying, hey, this has full bounciness, but the floor has 0 bounciness. So really it's averaging at about a 0.5, so it's going to bounce a little bit, but not a lot. We can also do minimum, and if I do that, it's going to take the lesser of the two, again, remembering that the floor is 0. And so what we're going to see here is really the ball just hits and stops. We can multiply, which again, we're multiplying by 0. This is really great for averaging between objects if you've got objects with different kinds of materials on them. But again, if we're multiplying by 0, the multiple or anything multiplied by 0 is still 0, so that's not going to work as long as this floor has no bounce. But we can switch to maximum, which basically, since I'm 1, means I'm going to be the maximum bouncy here, which is definitely that 1. And that's going to give me visuals a lot like what we saw before. I'm going to have this ball bounce, and it is bouncing a little higher each time. Because basically at 1, I am able to overcome gravity. So if I kind of move my mouse, you can kind of look at the horizon line here, and the ball is gradually, that was about halfway, that was a little over half. Now I'm more like 3/4. Now I'm all the way off the horizon. So if I keep on going and I just let it sit here for a second, it is eventually going to go off the top of the screen. It'll always come back, but it's definitely going to go there. If we adjust it to more of like about a point, I think the gravity factor is around a 0.9. Whoops, if I adjust this to about a point, let's go 0.8, it should bounce to almost its starting point, and then, but it should stay not going much higher. That's going down pretty quickly. So, but we could adjust this. We could tinker with this all day. So that's basically just some quick adjustments and some quick ways of doing bounce with your objects in Unity using just the built-in stuff. I'm going to be honest, for bouncing kinds of effects, again, I said this before, but typically I just code that kind of stuff. But this is a nice, easy way of doing it with very, very, well, no code on the bounce part. If in the 2D we used a little tiny bit of code just to get things launched in the right direction. So that's it. I hope that you found this tutorial helpful. If you did, as always, we'd ask you to like and subscribe. And thank you for joining us for this tutorial. Oh, as a quick review, we learned how to add physics materials in 2D and in 3D. We also learned how to create spheres and circular collision. And we also learned how to use the dot method directly off of the get component to manipulate a specific property. So we covered quite a few little things here in our half an hour. Hope that was helpful for you. And so we're going to go ahead and close. And always in closing, keep on creating. Thank you for joining us and have a great day.